I had no idea what this back and forth motion was called, so I decided to check ChatGPT to find out more. According to ChatGPT, it's called back and forth motion, linear oscillation, horizontal oscillation if it's on the x-axis. Some people call it shuttling motion, and more specifically in my case, it's a linear oscillation along the x-axis. So let's start with a 2D scene. This will be our root node. Let's just add and search for color rect. I'm using a color rect because you can add colors and so on to it. Pretty nice. You can click the red circles here and drag it to make it bigger or smaller, make the rect bigger or smaller. You can just click in the middle of it and drag it to the center of the screen. If you want to change the color, you can go to the right hand side here where the color is shown, click it and give it a nice color. I'll give it this purpley bluish kind of color. For now, this looks good. This is going to be shown exactly how it is on the screen. Save this, Control S to save, and I'll just give it the same name, Node 2D. There we go. If you look at the bottom left hand side here, you'll see Node 2D TSCN. So that's our scene there saved. If we run the scene, we can just run the scene alone, hover over it, you see run current scene, or if you click play runs the whole project. When you click play for the first time, it's going to ask you what your main scene is. So just select the current one, which is the only one we have for now. So as you see, it looks exactly like what we have here on the screen. If you notice, the screen bounds are similar to the screen bounds in the editor. If you look here, you would see the editor has a very thin blue line on the right and bottom, and that also continues on the top and the left hand side. The screen starts from here. In Godot, when you're dealing with coordinates, the x, positive x goes this direction, follow my mouse, and positive y goes in this direction, on a 2D scene that is. So, it's a little bit different from other game engines. For example, Unity, a positive y usually is an upward direction, but in Godot it's downward. So just remember that, because it's gonna be important when you're doing your calculations. Okay, now I want to add a script. Easy way, I'm going to the root node. You can create the script on the color rect. If you destroy the color rect, the script will be removed as well with it. So let's click Node 2D, and there's a little script add button here. Click that. It's going to ask you for the name. I usually choose empty, but you can choose Node default if you want. It's just going to pre-populate it with certain things that you can type in on your own anyway. Well, let's use it default for now so you can see it. Ready is called when the node enters the scene tree for the first time. So basically when you start the game or you start that screen, ready is implemented. So whatever information you want to be there when it starts, the scene starts, you put it in ready. And process is whatever is being run, the every frame call, and the delta is inbuilt into this, so it's very, very easy to use. For now, we're just going to use the ready. If I want to process, I will just put it back. So I'm going to delete process for now, and we're going to work with the ready function. Okay, so let me define two variables at first, do for the width and height. So variable var width of type int, or it can be type float, depending on how specific you want your calculations or you want your inner workings of your game. I use int because it's easier for me to visualize the information, but when calculations are being made in the background, especially for what we're about to do, is being done in a float mode, and the decimal part of the calculation is discarded. So let's say var width is equal to 100, and var height of type int is equal to 100 as well. Let's save this, Control S. Now if you run this, it's just going to give you exactly what we have already. Let's see. I think because we haven't put anything into the ready function. So if you want to change the width and the height of that rectangle, this pass is just a placeholder here. You remove that and you put your code. Okay, so we want to affect the width and height of the color rect. So how you do that is you can click the color rect on the left hand side and drag it across onto the screen. Make sure there's this tab here, this tab space right here, because whatever falls after the tab falls under the ready function. If you don't have this tab here, you're going to get an error like this. Godot is good at showing you errors. A little overzealous, but it's good for me. So you put back the tab, and you're referencing the color rect that we're going to affect here. And here, to change the size, the function that you can use is set underscore size. That's a built-in function, and as you notice here, it says to put the vector 2. The size is vector 2, and the rest are just overloads. So we're just going to deal with the size vector 2. So we're going to type vector 2, open and close brackets, and we're going to add the width, comma, and the height. It's an XY coordinate system. So the width is the X and the height is the Y. We save this, we run. Now you can see it's a perfect square with 100 width and a 100 height. What I'm going to do now is put something called @export. Can't even spell export. Export var width, and if you notice on the right hand side, the script is attached to the node 2D. So if you click the node 2D now, there's a value and the inspector on the right hand side for width. You can change this at will, and whatever is set on the inside here and saved, that is what is used in the game. Let's do the same for height. It makes life easy, because then it's easy to just change up values rather than having to come into code and change it. Let's save that. If you click play again, you'll see exactly the same thing because the values are the same. But if we change, let's say, the height here, you can just click and drag to change, or you can just click inside and change it manually. So let's say 100 by 200. So it's going to be a tall rectangle now. Let's save that and play. So as you can see, it's a tall rectangle. This is 100 by 200. I just want to point out something here now. Let's go back to the 2D view and click the color rect. When I click the color rect, you notice small crosshairs at the top left hand corner of the square, the box. That's the pivot. You can actually change the point of the pivot. So when you do movements like like scaling or rotating, those sorts of things, it goes around the pivot. Let's undo that, Control T. Let's move the pivot or the offset, let's say about 50, 50. So you'll see the offset move, the pivot offset. If we click rotate again and we rotate, you'll see all the movement is around this pivot. The thing about this, Control Z, right, let's return. The thing about this is I've noticed that Godot draws the rectangle and probably other shapes, probably even sprites. Don't quote me on that. It renders the shape from the top left hand corner. And why is that important? Because in calculations you need to take that into consideration. This is what I mean. Let's say this is our square and this is our pivot point here. When we're doing movement calculations, let's say we want to move 300 pixels to one side. The movement is going to occur from the pivot point, which means that if I move this box 300 points, which is from the front here to the end here, the whole box is going to move because the pivot point is at the top left hand corner and it's going to go off screen, which is not what we want. What we'll have to do is take the 300 and remove the width of the box so that when it reaches the end here, only the x extreme of the box reaches the end of the screen and it stops here. So back to the screen. Okay, let's go into the script. 2D. If you have some multiple scripts, it's going to show up in this little box here. You just click the script that you want. I want to manipulate the different properties of this color rect. So what I'm going to do is I'm going to put those changes in the ready function. So we already have the width and the height, which will be controlled by the width and height in the inspector on the right hand side here. Let's say I want to change the position. We can do the same thing. Sign color rect. It's auto included there. And set position. You also need a vector 2 position here. But your position is a vector 2 value. So, but what are we going to put here? Because it's a position. Let's go back to the 2D view. What position are we going to put? We can put any arbitrary position, but remember this is controlled by x coordinates and y coordinates. But this is a screen that's going to show whenever the game plays. So what we need to do to make sure that your values stay within the screen, what I want to do to get it to the center of the screen, I need to get the dimensions of the screen. I can do that physically by just clicking project settings and window, and you'll see here 1152 by 648, and I can use that and write equations to get the center of that screen. But I prefer the dynamic way to deal with that, a dynamic way to approach that, a more versatile way. I'm going to use properties of the screen to find the actual screen size. So let me get to that. I want to add a new variable here. Let's call it view size, maybe. You can name it whatever you like. And view size is going to be vector 2 as well. It's going to be the size of the screen. And let's, in the ready function, let's make it the first calculation that we do. View size is equal to, and we're going to use something called get viewport, get underscore viewport. So we're getting the actual viewport that that bounding box that we saw earlier, and we want to get the visible rectangle. So we get visible rectangle. That will throw an error because view size is a vector 2, but what we're getting here is a rectangle, which is information on the rect. Rect information is position, size, scale, all those different things that affects the rectangle. That's not a vector 2 information that we want. Vector is just x, y coordinates that we want. So what we do now is click dot size, and that works perfectly. We can run this, we won't see anything happen. Set position, oh yes, I forgot set position. We didn't actually set position. Let's comment that out. Save. Let's go again, let's run again. So the block is there, it hasn't moved. But we don't know if this new code addition is working. So let's put a print and print the view size. Save that. This is supposed to give you coordinates that is the size of the view, which is the bounding box here. If we close this off, you'll see in the background at the bottom here 1152 by 648, which is exactly what the project settings window information says. Now you can change the size of the screen here, but I'm not going to do that. That's not what I'm here for. Okay, so let's remove this print statement. And let's try updating the set position. Now that we have our view size, we can work that. Let's put a set position. Remember, this is a vector 2, so we can put it directly, and we can say view size, and you want half of the screen, so let's put half. But we have another problem here. Let's play it, you see. It's in the center of the screen, but the pivot is in the center of the screen, not the shape. I would like to get the shape itself in the center of the screen. So let's make some changes. What we're going to do is, instead of the view size, the full view size, which is a vector 2 variable that we have here, we're going to extract the x and y variables values. We're going to extract the x and y values, and we're going to use those to place the color rect where we want it to be. So let's remove this and type in vector. Don't forget, it's a vector 2 that we need. So it's x and y coordinates. You can't just put it as is, because set position requires, as you can see here, a vector 2. We can't just put a view size dot x, and that's how we get the x value, and view size dot y. That's how we get the y. But if you notice, set position wants the first argument is the vector 2, and the second argument is the offset. So if we just leave this as is, it's going to assume that the view size dot x is the first argument and the view size dot y is the second argument. which is not what we want. The first argument is supposed to be vector 2, so we need to enclose this in brackets and make it a vector 2. So let's block this off and with control brackets, oops, control Z, shift brackets. It's going to add brackets around and then go to the front of it and type in vector 2, and this makes it a vector 2. But this is, let's just save it and look what it's, we're not going to see the rectangle now, because guess where it is? The view size.x and view size.y is the full size of the viewport. So we placed it at the bottom here, and of course the top left hand corner of the rectangle is what is right at the end here, so we won't see the rectangle. So let's divide that by 2 now, and we're going to get exactly what we had before, but now we have the separate components of the x and y coordinates. Control save. So now we can subtract and add as we need. So we want the x value to go back by half the size of the rectangle, and we want the y value to go up by half the size of the rectangle. So we have view size dot x divided by 2, and let's minus the width divided by 2, and the view size minus the height divided by 2. So what we're doing here is we're getting half of the view size, the x and y coordinates, and we're minusing half the size of the box and the rectangle, and also the same thing with the y coordinates. So it's supposed to place it smack dab in the middle of the screen, and there we go. That's exactly what we want. Okay, let's add export. We're going to export it so we can manipulate it in the inspector if we ever need to change this variable. Let's add the speed here, because of course we'll want a speed that we can change if we're making some game or something. We want to be able to change the speed to something that we'd like, that works better for us. Let's say about 200. I think that works for me most of the time. We'll just start off at 200, and let's save this for now. We want to start moving this color rect across the screen. Let's start by moving in one direction at first. We're going to do this in the process. So function underscore PR, enter to autocomplete, and let's reference the color rect. We want its x position, so we're going to get its position dot x. If you're going to move this in a y direction, up and down, you can use position dot y. In my case, I want to move left and right, so I'm going to use position dot x. And let's just do this in one direction for now. The shorthand notation is plus equals, and let's say 1. Now this is the same as saying color rect dot position dot x is equal to color rect dot position dot x plus 1. This is just a shorthand for it, and it comes in really handy because it's less typing. So let's just save this and run. Press to save, and let's run the game and see what happens. So we have it there. The rectangle is moving to the right hand side of the screen. What happens if you want to move it to the left hand side of the screen? Well, if you notice here, 1 is the positive direction. You adding 1 to the x position every time. So it's going in a forward motion on the x axis, because that's x plus 1. You can put x plus 2, whatever. If you want to go backwards, then you have to go take away, minus from the x-axis. So let's put a -1 here and see what happens. So we're saying new position will be correct position x minus 1. Let's save this and run again. And there we have it. We're moving the other direction in the x-axis. Now watch what happens when it reaches the end. It disappears. We don't really want that behavior. We want it to bounce back, but we'll deal with that after we deal with some other things. Let's just make a totally different variable for the direction, and we'll call this var direction. It's of type int, although you can use a bool, true or false, but I'm using int because I want to multiply by 1 or -1 for the direction. So, and let's say it's equal to 1. So in the beginning, we're just going to move to the right direction, and somewhere along the game, when it hits the right side of the screen, we want to switch back, move it to the left direction, and when it hits the left side of the screen, we want to switch back to the right. So we're just going to change the variable direction into -1 whenever it hits the other side of the screen. And let's apply that down to the bottom here. So just to see, so it's direction. And remember, we have delta here. Let's multiply delta. Delta normalizes the speed of the movement or whatever you're using time for. Right now it's controlled by frame rate, and different computers can have different frame rates. So if the frame rate is too high, the game can move too quickly. If the frame rate is low, the game can move slow. But by using delta, you can always look up delta and see its meaning, but basically it normalizes the speed dependent on the frame rate of whatever device is being used. So we're just going to add delta here. Let's save this and run. So you notice how slow it's going. That's because we use a delta, and delta has normalizes speed according to the CPU specs and the frame rate of my computer. If it was a more this is just a laptop. If it was a more powerful computer, it will move faster, and that's okay. That's why we have the speed variable. So let's add speed now. Let's multiply speed, sorry, not add. And we have speed at the top here. Speed is 200. So what we're saying is the direction is 1, which is a positive x value, a positive x direction. We're using delta to normalize the speed regardless of what device is being used to play this game. It's going to move at the same speed, and we're multiplying by speed to speed up that value because it's too slow on this computer. So the game doesn't move differently on different devices. Let's save that, control save, and play. So there we go. That's a fairly nice speed. What do we want to do now? When it reaches the right side of the screen, we want to bounce it back, and when it reaches the left side of the screen, we will bounce it back. Okay, remember when I was describing the movement? When we want to move to the right, we're going to move this whole block to the right. And when the right end of the block, not when the pivot, which is at the top left hand corner, when the right end of the block hits the right end of the screen, we want to stop and send it back until it goes in the other direction. And when the left end hits the screen, the pivot is right here on the left as well. We have to take into consideration where the pivot is when we do these calculations. So let's go back to the other screen. So I just want to do this calculation in a separate function to make life easy, and we can just include that function after this first function in process, after this first line in process function. So let's go at the bottom here and func. Give it any name you like. I'm going to call it back forth for back and forth. And open close brackets. Colon, new space. You can also put, it's not going to return anything, so it's void, so you can just leave this colon as is, or if you want, you can add this whole line here, the arrow with the void, Control C, and put this right here, and Control V, and that is also okay. And what I'm going to do here is use some if statements to check when the right side of the block reaches the right side of the screen, and when the left side of the block reaches the left side of the screen, and make the block movement react to when it reaches those extremes, bounce back and go the other way. We use an if statement, and let's say if the position, I keep on forgetting, if the position of the color rect. So if the color x position that is, dot position x is more than or equal to the view size x value. Remember, we want when the right side of the box, the right side hits the right side of the screen. So we have to minus the width of the block because the pivot of the rectangle is at the top left hand corner. So we are going to minus the color x size value, sorry, dot size dot size dot x, the x value of the size. So if the color x position is more than where the right side of the square hits the right side of the screen, we are going to change the position. We're going to reset the position, because what can happen is the block can actually go across the screen if you don't reset it. So we're going to make sure it stays at that position. So we're going to say let the color rect position x position equals this exact information here. Control C, Control V. So we're resetting it, and we can run this now. Of course, we'll have to include it in the process function, so let's include it one time. Let's just put back forth. So now when we run this in the process, the box is going to go to the right hand side and just stop there, because all we're doing for now is just resetting the position of the color rect to the right side of the screen, so it doesn't go beyond the right side of the screen. We'll save and let's run. And that's the very behavior we want. Now we want it to bounce back to the other side, so let's do this. So we also want, after this, we want to change the direction. So because in process right now it's going in whatever direction it is set to, and our direction is set to 1 at the beginning of the game. Let's change direction to -1. So let's just, that's simple, just say direction is equal to -1. And that's it, it's going to move back to the other direction. So let's save this and try it out. But when it reaches the left side of the screen, we didn't make any if statements for that. So of course it's going to disappear across there. It's just something similar. Let's go down one bit, and make sure you're directly under the if statement, and we're going to use an else statement. Else, make a next space, make sure there's a tab to the next line, or else if the position of the color rector, the x position, is less than 0. Now remember, we said when it comes this way, the pivot is on the top left hand corner, so that will be the position of the whole rect when it touches the left extreme of the screen. We want it to stop there, not go any further, and want it to bounce back again. So it's basically the same code, just the other direction. So if the color x position is less than 0, we want to, don't forget to tab again, we want to make sure we freeze its position, its x position, at that 0, so it does not go beyond, and change the direction back to 1. And that's it. That's all we really need for the back and forth motion. We're done. Let's save. Oh, I'm seeing an error. Yep, that's because this if statement doesn't have the colon at the end of it. Just like this statement up here, there's a colon at the end because that's the beginning of a block statement. Anytime you have a beginning of a block statement, you have to finish it off with a colon. So let's put a colon. My mistake. Everything's good to go. In Godot, let's look at this. It touches the right side, bounces back, touches the left side and bounces back. And this is exactly the behavior we wanted. This is what we set out to do, and I hope you enjoyed this. Please comment if you have any questions. I'll try to answer them. I will try to come up with another video of something that I have in my game that I'm building. I've just started building the game, but it's my very first real game, and I'm using some of these mechanics as well. So I'm glad to share them with you for you to use in your own games. I hope this was informative to you, and see you in the next one.